does Ladyada?
Hey everybody, and welcome to my desk. It's me, Lady Ada, broadcasting at random hacker times. And it's a little bit later, sometimes a little bit earlier. But we got a lot of stuff going on my desk. First up, Mr. Lady Ada, who's behind the mic and video cam. Is there any news or updates for anything you want to tell people?
No, only that I have a mic on Kiddo, and you can hear. She likes playing with crinkle paper,
Crinkle.
and then she has this little squeaky thing. And then there's a couple other things that make noise, but we'll see if she says anything. I'll put the mic on her.
Baby is still alive, and it's been 91 days.
Yes, it's working out.
Okay. Over my
Anyways,
desk.
take it away.
Okay, so let's go to the computer, I think. So we can get the computer stuff out of the way. So folks, I talked about this a couple weeks or months ago. I've been updating all of our testers that were originally using a TC36, which is a great processor, and I would have kept using, but it's unobtainable right now. And we used we were using that tester bed to program our RP2040 boards, some ESP32 boards, our SAMDs, like basically things with a microcontroller that were more complicated than just a sensor. If it's just a sensor, we'll use like a Metro or Arduino basically to test it. But if you have to program it, you need something that has like an SD card to hold the firmware and is fast enough to bit bang the SWD protocol, or use USB host to communicate with the USB peripheral on the chip. But since you can't get the TNC36s anymore, I decided to try updating the design to use a Pico. And we showed this off on previous videos, so I won't go through the details. But basically, you've got your RP2040, micro SD card, piezo, USB host that we use bit banging to interface, semi-QT, the port that goes to the device under test. So like the SWD pins here, you can see UART, I2C, power control, so you can like turn on and off the power. Character LCD reset button, and mounting holes. And UART RX TX switch, so you can, when I mess up which way is RX and TX, we just flip the switch the other way, and it suddenly starts working. So folks wanted the files. The files are now on GitHub under RP2040 based Tester Brains PCB. The only thing is it's super unsupported, mega unsupported. There's nothing more unsupported. It's like 11 out of 10 on the unsupported dial, because there's no way for me to, I use it for internal usage only. We don't sell it. It's just that some people might find this useful. There's some videos, the previous videos, where we covered this thing. It's open source. Go ahead, fabricate it. I tried to make it as much surface mount as possible. So we put stuff like this through the oven, but you would have to hand solder it. But it's not too bad. You also convert it to more through hole. And then, so we had already converted all of our RP2040 designs. Sorry, anything that we were programming in RP2040. So like the KB2040 tester, the Feather RP2040 tester now uses that brains as the board, and it programs the RP2040 over USB host. And so this week, what we've been working on is, let's see, under test bed. This is also, again, it's like totally unsupported, but we publish it. It's a library that we use for testing stuff, both self-testing and programming. So what has been added this week is TAC and I are working on adding support to programming ESP32s. And you can program ESP32s over UART, and they use this very simple, like packetized, like you send a response over the ROM. And we use this for our web-based flasher. Of course, ESP Tool uses this as well. And so this is just a port, basically, of ESP Tool, this boot ROM code that I wrote like forever ago. Oh, sorry, this was originally part of the Arduino Maker updater code, and I hacked the heck out of it. So it is based on their code. I'll say, like, I modified it, but I was using this for programming the PyPortal, because the PyPortal has a built-in ESP32, and I wanted it to self-program that module. So this library works pretty well. You sync the data, you connect, and then you send UART data, and it autobaud, so you can use up to like 921 kilobaud. There's only one thing that we notice, which is this works wonderfully on the classic ESP32s. Like I'll show you on the Pi portal. Well, I'll show you. So the Pi portal uses the classic ESP32 room, and this is like kind of like the first ESP32, and so you can do everything over the boot ROM directly, and this could program just fine. But then I was like, well, I want to, the first thing I wanted to do was program the Feather V2s, these new Feather boards that we have with the Pico ESP32, and I was like, the Pico ESP32 is just a room but smaller. It turns out actually no, it's not. You do need to have the stub loader. You can't program it without the stub. And the stub is this piece of stub. It's this piece of code. So like the ROM loader can like do some basic stuff like program flash and load stuff into memory. And I probably could eventually get it working with the ROM loader to program that Pico, but like it's like really slow or something, or it's not responding, and I don't quite know why. So basically, the ROM loader is very bare bones, and what they're expecting you to do is that you boot up the loader, the ROM loader, and then you insert like a very small program that takes over the hardware and then does the rest of the bootloading out of RAM. And this is actually very similar to how the IMX series does it as well. The bootloader, when you program it from USB using like the the NXP programmer tool, I don't remember the name of it. It's from like 3 weeks ago. We were showing it off. We load TINA USB into the TINA UF2 into RAM, and then we execute from the location that we loaded it into, and then that actually does the programming. Like you can only program into RAM, and then the RAM is where like it you jump into there, and then that takes care of the rest of it. So it's kind of like a secondary loading technique. So the stub has to be flashed in for these V2s, the minis and the Picos, which we kind of want because again, I want to. I'm updating a bunch of designs that originally used the Waroon module to use the mini or Pico module because it has like PSRAM built in and it's inexpensive. So to do that, what we're doing is loading this, and the stuff is like, while they say like, here's what you do, it's not really documented what it is. So what you do is we run ESP tool to program the chip, and we when you call ESP tool, you add a -T for trace mode, which is really nice. And trace mode gives you the full byte dump of like what it's sending and what's receiving. So like, all the bytes that are sending and received. So like this is I think the beginning of like, okay, I'm going to write the stub, and then this is actually the stub. The stub itself, I wouldn't extract from here. There's actually the hex code is in the Python. But just if you want to compare and contrast, like, well, what does it look like when you're writing versus what I'm doing in C? So right now we're trying to figure out like, we're trying to load the stub and execute. It's not quite working, but we'll get there. It's like, it's just a matter of you just go through the trace and eventually you get to everything in the trace. So that's the next steps. So then after that, we'll also do DAP. So if you want to, so that's RP2040, ESP32. AVR, we already have available. It's in a library called AVR Prog, which you can program both. Oh, somebody's telling me to do this. You can program AVRs over ICSP, which is like the reset mostly MISO S clock interface. And then the modern chips like the AT Tinies get programmed over UPDI. So we also have a port of UPDI, which I grabbed from somebody else's standalone thing. So that's all the AVRs. And then the last thing would be anything that uses SWDAP, which is like, Cortex M0s, not the M7, because the M7 is like kind of complicated and has a built-in, USB bootloader. And we also don't use SWD DAP for the RP2040 because the RP2040, it has like this weird dual core DAP thing, which is like a multi-tap. And also the USB is like really simple. It's just mass storage. So we just use that. For in general, by the way, the transport by which you program the chip usually doesn't have a huge impact on the speed because chips are time bound by the amount of time it takes to flash or erase the flash memory. Like that's what takes time, not sending the data as much. Although you do want to have that as fast as possible. So for DAP, just for the folks who are interested, we do have. Oh, that didn't work out. Adafruit DAP. So this is our code that you can program SAM chips and STMs and NRFs, and then people maybe can add, hopefully, I mean, there's no pull requests, but once in a while people submit a PR and they're like, hey, here's how to program a variant of one of these chips in situ. So slowly but steadily, we're using Raspberry Pis to program the ESP32s, but I'd love to. And the Raspberry Pis, believe me, they're great. But even those, it's like they can get flaky and they can have power dips. Whereas the having something that's fully firmware, solid state, there's no operating system. Even if it's a tiny bit slower, you can have multiple of them running at the same time. Whereas the Raspberry Pis are kind of like they're not delicate, but they're you can't just unplug them and they can get corrupted and the SD can get full. So it's one of the things that we're planning on doing.
Okay, question. Because this came up before, and I think you might want to put a note for this. So the PCB designs that help that aren't products, the RP2040 bones files. How can folks get those? Because I don't think we have it as a specific.
I haven't published it.
You haven't published it.
I have not published that yet because it's not tested. I have no idea if it works.
Okay. All right, so that's the reason why folks can't find it.
Yes.
Okay, but it will be like all of our stuff.
Oh yeah, it will be. But like I would, I don't want to publish something and it doesn't like I should at least get it working somewhat. Like the tester brain somewhat works. It's not all tested.
No, I'm talking about remember the not this project that you're talking about, the RP2040 feather bone file.
Yeah, I'm saying I haven't tested it.
You haven't tested it all.
So I'm not going to publish it. I'm only publishing this because I've tested it.
Okay.
Yeah.
So yeah.
Yeah, I don't publish stuff until I've at least made a prototype.
There you go. All right. So when you do though, let me know more, and I'll get the word out. So there's a couple
video.
Yeah.
We'll do video.
Yeah.
It's basically the feather though. It's like it's not that different. You can take the feather and
start doing it if you want. Okay. Yeah. Cool.
Okay. Any other questions?
Nope.
Okay. Is that everything? Sorry, I don't have the text in front of me. Is that everything I had in the?
Well, let's see. For the greats, we're doing the great search. This is this week. More RPA R2040 tester brains. You did the flammers. You moved over GitHub. Yeah. Let's hit the great search.
Okay, so it's great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses her power of engineering to help you. Yes, you find the things that you want on digikey.com. Ladyada, what is the Great Search this week?
Okay, this week I am looking to replace the low-cost Class D amplifier that I've been using in so many of my designs. It's gone NRND, not recommended for new designs. And one thing I've learned over the chip shortage is that once you start seeing that, try to get away from that part as quickly as possible because it can, it used to be that things would go NRND, but you'd still be able to get them for a while. I'm actually a little nervous about that now because I got bit a couple times by parts that were NRND and then immediately disappeared, evaporated, and there was no last time buy. So let's go to the computer real fast and I'll show off this chip and then I'll go to the overhead later. So on a lot of our boards, we use this little speaker. This is a 7.5 millimeter by 7.5 millimeter speaker. They're actually available on DigiKey too. There's magnetic buzzers, and they're a jelly bean part. They come in a variety of different makes. And they're, about like 50, 60 cents in quantity. So these are a great alternative to plug-in speakers. They're inexpensive. As you see, they're fully surface mount. They come in tape and reel. So unlike piezo buzzers, you can solder them in. and they're fairly loud. The only thing that's a little bit iffy about them is they use a fair amount of current. They are magnetic, and they require 100 milliamps. So it's not, a ton of current, but it means that you can't just drive them from a microcontroller pin. You're not gonna get the nice strong tones. That's different than piezos, which you pretty much can drive from a pin. So what we've always done is, as you see here, this is the buzzer, and this is the audio coming out here, and this is the two pins of the inductor. Inside there's a little disc that vibrates. Is we have this PAM 8301 Diodes Inc. Class D amplifier with like 6 pins. It's a very inexpensive part. It's like 15 cents. And it basically has like audio in. You put a 0.1 microfarad cap on the inside because it's very high impedance, and so you don't need a big blocking cap. And then you have like one shutdown pin, power, ground, and then 2 Class D bridge tied load outputs. And what's nice about the Class D is, first off, it's fairly power efficient. It doesn't heat up the coil by having a bias go through it. Because it's Class D, it's differential. You don't need blocking caps. It's just overall like a really nice design. And like I said, it's very inexpensive at about 15 cents. Without any, you only need one. I put like a filter on the inside, but basically you only need a resistor and a capacitor to run this thing. It's low on component cost. It's easy to pick in place. It's about the same price as a couple transistors. So it's like, why don't you just do a Class AB? It's about the same price, and you get like a Class D performance. It doesn't sound too bad either. So let me go. I don't know if this is gonna work, but hold on. Whoops, go here. So this is. Oh, 1 second. It's got hooked. So this is the speaker. I don't know if you can hear that, but it's on a macro pad, and it's just kind of doing a little boopy boppy. And then you can do one thing I like to do for a lot of projects is I just have a little coin, like a little indicator coin. So it's like a beep. It's not a very loud effect. And that's again using the PAM 8301 with this little amplifier. Okay, great. But I'm going to DigiKey, and they helpfully tell me, well, there's lots in stock, but they're not recommended for new designs. And the substitute is actually like there isn't any of the substitute in stock either. So I thought what we would do is we would find a substitute for this. So what we're looking for is it's going to be a Class D mono, because I need to be small and cheap, and it's the smallest and cheapest is going to be always mono output Class D. The power per channel, I mean, as long as it can drive basically 8 ohms, the wattage doesn't really matter. Another nice thing about this amp is it would run from about 2.5 to 5.5 volts, and so you could use it with 3.3 or 5 volt power and logic. In fact, what I would often do is power the amplifier from 5 volts or battery, whatever is the highest voltage I have on the board. But then, the logic level that goes into it is 3. And of course, I want it to be surface mount. The package, I don't know, I might not be able to get SOT 23.6. And in fact, actually, sorry, well, yeah, quickly I'll go here. So at diodes.com, you can search for the parts. It's like, well, what do they have? And they also say, yeah, it's not recommended for new designs. And if you go to the data sheet, they do have a couple recommendations, which we'll see. So this is another good place to go look for recommendations at the top of the data sheet. Diodes is going to have a better idea of what they stock. That's a better option. And then this is just the usage scale. So you can see it's like, I love this thing because it's so simple. You just have like, coupling cap in, power supply, speaker out, shut down, you're done. Don't need anything else. No gigantic blocking caps. Okay, so let's find surface mount mono Class D in the amplifier category. We're going to look for active because that's what we want. And normally stocking. So let's see what's available. And pricing isn't really kind of important to me, so I'm going to look for pricing at like 5,000 pieces or more. So there's a couple of good options. So one of the options that is recommended, so this is the unfortunate thing, is that they're like, okay, why don't you just use the 8013 or 812, 8013 or 8014. Well, these are very affordable. They're about 20 cents, but they're both BGA package. Now, I will say that the BGA package for this one in particular, if you don't need to use the N pin, if you don't mind having it be on all the time, you can tie N to VDD, and that way you don't have to, because this is a 0.4 millimeter pitch. So, you're dealing with either a fan out or or like a via in ball pad. I'm not a huge fan because I like to keep my manufacturing simple. The 8014 is a little bit nicer because at least the center pad is the power PVDD. So, you know, yes, it is also a BGA, but at least you can tie the center pad out here, and then because you're probably going to be using the same power as VDD. But would like to avoid that. So the next options are the 8302 and the 8304. Both of these are, sorry, the 80304 is actually recommended. So the 8302 is a little bit older. And I'll show you the comparison because I actually use the 8302 a lot. So one thing that is nice is, by the way, the 8304 is available if I needed it, that small space, it's available in this tiny DFN 3030. The biggest difference kind of for so 8302 and 8304, let's go to the right here, is the 8304 will give you 3 watts into 4 ohms. That's another thing. These can go into 4 ohms, which is quite a bit. But the voltage range is a little bit different. This one, it's closer to 3 volts. This one goes down to 2. Are you running it off of 2 AA batteries? Then maybe you'd want to use the 8302. Whereas if you're can guarantee a 3.3 volt power supply minimum, you can go with the 8304. Both of these actually are pin compatible as well. And then the PAM 8304 also is available in DFN. This is another option. This wasn't in stock, but I did take a look at it. This is a little bit, the part number 82011 is like, okay, they're obviously kind of getting in on that PAM 83 series. Also very similar, pretty much the same setup. There is differential inputs with this resistors and capacitors, and then an output driver. This one just has I guess they just have a standard package that they use. But that said, so what I ended up doing is I do like the 8304, but the fact that the 8302 is just like there's more in stock, and I do already stock it, I'm pretty much just going to redesign everything that used the 8301 to use the 8302. And it's basically the same. It's actually the same gain as well. So what I did, if you can go to the overhead, is I have this is a PAM. Oh, hold on, let me focus lock. This is a PAM 8302 amplifier, and inside there is 24 dB of gain. And I just took off the I had a terminal block here, looked like this before, and I just hot aired it off and soldered on one of those little speakers. And then on the original design, there was a little potentiometer. But what I did is I kind of removed, to mimic what the 8301 would have. I replaced the input resistors and capacitors, and then put a little a low pass filter here, because the output from this RP2040 is high frequency PWM. So this comes in, the high frequency is kind of filtered a little bit to smooth out, even though the Class D kind of, obviously it's high frequency as well, but it does remove a little bit of the hiss. And then in here, there's a little bit of a input gain modifier. So the default gain that these have is 24 dB. which is like 5 times gain. Can't remember off the top of my head, but I want 1-to-1 gain because I'm actually getting 3.3 volts output from here. So it's actually kind of like it's like a current booster voltage follower. It's actually a very not really amplifying. I mean, it's current amplifying, but it's not voltage amplifying. So what you can do with these, I'll show you. This one of the data sheets does not have a diagram of the internals, but one of them does, and I think it's this one. Let me show you it. Oh, can you go to the computer? Sorry. Pardon me. So this is the inside, and so you're like, okay, here's how you wire it up. You have differential input. They just have a blocking cap. But what's inside actually is here's that. Sorry, it's 15 gain. So there's this 15 times gain because they're expecting you to give it, a couple millivolts, maybe 100 millivolts peak to peak signal, and then it boosts it up and drives your output to 3, plus or minus 5 volts differentially. However, because I'm my input is 3 volts peak to peak already, and I want basically 3 volts output. What you can do is you add another resistor here, 150K approximately, and that turns this gain into 1. So this normally is 150K over 10K gain. So you add another resistor on the input, and so let me show you what that looks like here. This is 300K. Ignore these values because these values are not correct. But by adding, like if I have this be, like 140K, this is 140K, and this would actually be 0.1 microfarad. Now I have unity gain. You still have to, even if you have, by the way, it's differential input. If you have single-ended input going into this chip, you'll still need to have this filter going to ground to balance out the differential input. But now I've got the same 3.3 volt in, 3.3 volt out, driving directly to my speaker. You don't need to have a ferrite capacitor output, but it's nice if you can fit it on your board. Still very inexpensive, and I always get very nice output from this. Also good for little speakers, and it's up to 3 watts, so you can use this for fairly large 4 or 8 ohm speakers. So this is my pick for the Great Search.
That's a great search.
Where in the world is that part I need? The Great Search with DigiKey.
Alrighty, let's do some questions.
Yep.
Are you ready?
Yeah.
Is there any reason that an end user might want to reflash what these tester programmer boards are doing? Perhaps security issues or Wi-Fi devices?
I mean, they're for anything. I mean, like they're just if you want to automate any kind of programming and testing, that's what they're for.
Okay.
I use them for programming, but it's got USB host, SD, LCD, button. It could be useful for a lot of things.
Does logic voltage versus power voltage matter? Like you said, use BAT 5 volts and 3.3 volt logic, but would 3 volt input and 3.3 volt logic work?
Yeah, I mean, you just want to have the power. The power should be as high as the best power supply you've got, right? Because you're driving a speaker, you need a lot of current. But the analog signal can be any voltage.
Okay. Next up, with the iSpy connector, is there a library or documentation to use a MEMC over SPI?
A MEMC? What did they say?
Yeah, MEMCS. Sorry, MEM.
Oh, MEMCS.
Yeah.
Oh, it's just if there's an external flash memory, you could use that as the chip select.
Okay. And then next up, what's the difference between DFN, QFN? I don't understand the naming convention for these SMD footprints.
The D is for dual, so there's pins only on 2 sides. At QFN, there's pins on all 4 sides.
Okay. Why
why.
reduce the gain to 1?
Because my input signal is 3.3 volts, and my power supply is basically also 3.3 volts, and so I don't want to amplify the voltage. I just want to amplify the current.
All right. And check some other things. Looks like them's the questions.
Okay.
All right. Well, thank you, everybody. Kiddo fell asleep here, so no more
Too much excitement.
no more crinkle or squeaky sounds. She's asleep.
Time for fast.
So we'll see everybody during the week. We got some shows and more. Lots of fun surprises. Thanks for joining us on this Sunday night. That is Desk of Ladyada.
Good night, everybody. Have a great week.